All right, let's talk about some more applications of the derivative. So this section, we're going to talk about how to find the maximum and minimum of a function. And so we're going to introduce this term that you've probably seen before, relative max or relative min. That's opposed to the absolute max or the absolute min. So the absolute maximum would be the absolute max. It'd be the greatest value that the function attains on a particular interval. It could be on an interval, or it could be over the entire domain. Relative max or relative min, if we talk about the relative max, then we are just talking about some high point on the graph. So it may not be the tallest point on the graph. So if we look at this one, we have this function that follows this curve. And so the function continues to increase to infinity. So there is no absolute maximum. You can always find, no matter what y value you want to find, you can always find one that's higher than that. But we do have a couple of places where we have a relative max. So relative max just means that there is a neighborhood where this function attains this maximum or attains a maximum. Same thing with the minimum. There is a neighborhood where it attains a minimum value. So, and here's another relative max, here's another relative min. So when we talk about a relative maximum or a relative minimum, that is what we mean. So if you want the mathematical definition, then f of c, so c is some number in the domain, f of c is a relative or local maximum if there is some interval a to b. So this is any interval containing c, where f of x is less than or equal to f of c. So f of c is greater than f of any number in this interval. And in that case, it would be a local maximum. Now, once you get outside AB, that interval, you could have values of f that are greater than f of c. For instance, if we keep drawing this one up, then some value up here is going to be greater than f of x1 or f of x3. Same thing over here. If we keep going down, eventually we'll get to a point where f of x5, let's say, is less than f of x4. So, so that's what we mean by relative maximum or relative minimum. Now we have what's called the first derivative test. And so the first derivative test is a way to find a relative maximum or a relative minimum. And so if you think about this is kind of common sense when you think about it. Maybe you hadn't thought about this. This is one of those things probably you kind of know but haven't really thought about. So if you want to get to a maximum, you have to increase up to a point, and then you have to start decreasing. You can't increase and keep increasing because then that's no longer a maximum. So if you have a graph and you're increasing, and then you say this is the relative max, but then you keep increasing, obviously this is not a maximum, relative max. So to get a relative maximum, you increase, and once you get to the maximum, you start decreasing. And then to get to a relative minimum, you're decreasing, and then once you get to the relative minimum, you start increasing again. Now, what does that tell us in terms of derivative? Now, this is the part you need to make the connection between the visual and what you can intuitively see and connect that to the calculus that we've been learning. So if the function is increasing, that tells us that the derivative is positive. If the function is decreasing, that tells us that the function is negative, or the derivative is negative, I should say. So increasing, the derivative is positive. Decreasing, the derivative is negative. So let's write this in terms of relative max and min. So let's call this C, and we have some interval, open interval A to B. So C is somewhere in that interval A to B, and this is our neighborhood. We know that from the definition on the first page that f of C is going to be greater than f of x for any x in this interval between A and B. So now, so we can say we know we're increasing from A to this point C. So that means that f prime of x is greater than 0 for all x in this interval. So that symbol means that x is in this interval A to C. So if we're prior to C, f prime of x is going to be increasing, or f of x is going to be increasing, which means f prime of x is going to be positive. And then after C, f prime of x will be negative because we have to be decreasing. So f prime of x is less than 0 for all x in this interval C to B. So in this part here, we would have to be decreasing. Okay. So if we have, increasing, then decreasing, we're just kind of shorthanding this. Increasing and then decreasing means we have a maximum. Or to put it in terms of derivative, f prime of x greater than 0, then f prime of x less than 0 means we have a maximum. And then we can reverse this, and that gives us a minimum. So if we have decreasing, or let's write in terms of the derivative, f prime of x is less than 0, that means we're decreasing. Then f prime of x is greater than 0, that would mean we're increasing. So we're decreasing, then we're increasing. That makes a minimum, a relative minimum. Now, if we draw a picture of this, if we know it's less than 0, we know that's decreasing. If we know we're greater than 0, we are increasing. So wherever that turn is, wherever C is, that will give us our minimum. And likewise here, if the derivative is greater than 0, we're increasing. If the derivative is less than 0, we're decreasing. So we have these, this is how our curve is kind of going. So right up here, we'll have our maximum. So that's how we want to think about these things. Again, you want to get to where you don't need the graph. In fact, in a couple of sections, we're going to be drawing the graphs ourselves. So we need to get to the point where we can we can do these things without needing the graph. So let's look at an example. So we're going to find all the relative extrema of this function. And so this is a polynomial, so we know that the domain is all real numbers. So let's take the derivative. I think I said in the last video, or the last section, that the first step in pretty much all these problems is to take the derivative. Very standard. So we have 6x squared minus 6x minus 72. And then usually, almost always, we're going to set that equal to 0. And what does that give us? If we set the derivative equal to 0, that tells us what the critical points are. So let's factor out a 6. So we get 6 times x squared minus x minus 12. Then we can divide by 6. We can factor this. We get x minus 4, x plus 3 equals 0. So that tells us that our critical points are x equals 4 and x equals negative 3. Now, with polynomials, you can actually, if you can figure out what the graph kind of looks like. And then that will tell you which one of these is a max and which one is a min. And maybe it's possible they aren't either. So it is possible you could have a graph that looks like this. Now here the derivative is 0, but it's not a max or a min. So we're gonna test this out. So we know for sure from this that f prime of 4 equals 0 and f prime of negative 3 equals 0. So that tells us that those are critical points. It also tells us that we need to check what is going on either side of these critical points. So let's figure this out. Where are we increasing? Where are we decreasing? So this is what we did last time in the last video. So we need to test some point over here that's less than negative 3. So let's just pick f of negative 4, f prime of negative 4. So f prime of negative 4. And you can actually use this factored form to your advantage to save you a little bit of time. So imagine we plug in, because the 6 doesn't change the sign, we're just multiplying by 6. It's still going to be positive or negative before we multiply by 6 and after we multiply by 6. That doesn't change the sign. So if we plug in -4 to this, we have -4 minus 4, -4 plus 3. Now, you don't really need to write this out, but I'm writing this out so you can see what is going on in my mind. If we plug in -4, that is a negative, and then -4 plus 3 is also a negative. So that is going to be greater than 0 because we have a negative times a negative. So that tells us that we are increasing from -infinity to -3. Now let's plug in any number between -3 and 4. 0 is the easiest. And here we can plug this into the original derivative that we get, and that would be -72. Oops, -72, that's less than 0. So here it's greater than 0, we're increasing. Here less than 0, we are decreasing. So what does that tell us? That tells us that we are increasing and we are decreasing. So this one will be a relative max. Then let's check a number after that's or greater than 4. So let's just try 5. And so we can plug this in. You can plug this in if you want. I mean, you have a calculator, so you can plug it in. You can also plug it into here. And if you plug in 5, you get a positive number times a positive number. So it should be a positive, but you can plug it in here as well. But I already know it's going to be positive, so I won't get the answer. I'm not worried about the answer. I just want to know if it's positive or negative. So this is positive. That tells us we are increasing after 5. So here we are increasing. So now here we're decreasing. Then we go to increasing. That tells us that at 4 we have a minimum. All right. So let's find out what the maximum and minimum values are for the relative max and relative min. Obviously, this goes down to -infinity that way, goes up to infinity this way. So there is no absolute max or min, but we can get the relative max and the relative min. And so how we do that is we're going to plug 4 and -3 into the original function. That gives us the original function up here. So that gives us the maximum value of the function or the minimum. So now the relative max happens at -3. So f of -3 is 150. So you plug a -3 into the original function, you get 150. The relative minimum happens at x equals 4. F of 4 is -193. So there's our relative min and our relative max. So the minimum occurs, let's say relative minimum. The relative minimum occurs at x equals 4 and the relative minimum is -193. And then we could say the relative maximum occurs at -3, x equals -3, and the relative minimum is 150. So that's how we want to talk about these things. So step 1, take the derivative. Step 2, set it equal to 0. Step 3, figure out where you're increasing and decreasing, and then that will tell you your max and your min. And then step 4, plug your values, plug your critical points back into your function. So let's write those down. So step 1, take the derivative. Step 2, equal to 0. Step 3, find critical points. Step 4, find your increasing, decreasing intervals. Step 5, plug critical points into the original function f of x. So let's do the same thing with this one. Let's find our derivative. So f prime of x is -3x squared minus 4x plus 15. Set that equal to 0. Let's divide out the negative. We get, when we factor this, we have 3x plus 5, no, 3x minus 5, and then x plus 3 equals 0. So we get our critical points. X equals 5/3. X equals -3. So now let's find where we're increasing and decreasing. So put -3 and 5/3 on the number line. And so now let's test. So if we pick a number less than -3, let's say f of -4, and you can plug it into the factored form again if you like. So plug in -4, that factor is going to be negative, and that factor is going to be negative. So that tells us that that actually is not right. Where did we go wrong? It should be negative. Yeah, so we actually need to plug it in here because plug it into the original because here we factored out the negatives. So that's the problem. So if we plug in -4 into the derivative, I'm not sure what we get, but we get a negative number. So negative number, we are decreasing. Now plug in a number between -5 and 5/3. Let's pick 0. Plug in 0. This should say f prime. F prime of 0. Plug it in here. We get 15, which is positive. It's going to be increasing. And then pick a number greater than 5/3. Let's just pick 2. So f prime of 2. And I believe this one is also going to be negative. Now, it's tempting to assume that these will always alternate, but they don't. They don't always alternate. Most of the time, probably they do, but they don't always. And it's not a guarantee ever that they always do. Even with the polynomial, any type of function, it is possible that you could have a critical point, but then you have increasing, or decreasing. Like it doesn't have to alternate. It does not have to alternate. But it does here, and we know that this will be minimum, this will be maximum. All right, so we have relative min at -3, relative max at 5/3. And then we can find f of -3, and that gives us -26. And we can find f of 5/3, and that gives us 670 over 27. So there is our max, or sorry, there is our min, there is our max. So just to illustrate the point very quickly that these don't always alternate, look at f of x equals x cubed. So that gives us f prime of x equals 3x squared. Set that equal to 0, x equals 0. All right, so we put 0 on a number line. Now pick a number less than 0, plug it into the derivative. That's going to be positive. Pick a number greater than 0, plug it into the derivative. So say 2, 3 times 2 squared is going to be positive. So these are both increasing. So what does that tell you about 0? That tells you that 0 is neither max or min, nor min. And if you look at the graph of f of x equals x cubed, it looks like this. And so there's our critical point, but all that means is that the derivative is 0. It doesn't mean that it's a max or a min. So just because the derivative is 0 does not mean you necessarily have a max or a min. In this case, the function is increasing the entire time. At this one point, the derivative is 0, but it doesn't change direction. All right, so let's look at a different type of function. So we have 6x to the 2/3 minus 4x. So let's take the derivative. F prime of x equals 4x to the -1/3 minus 4. Set that equal to 0. So 4x to the -1/3 equals 4. X to the -1/3 equals 1. So x equals 1. Now, we also have in this one that x equals 0. That is also a critical point because it is not in the domain of the derivative. So both of these are critical points. Now, with polynomials, you don't have to worry about a number not being in the derivative because the derivative of a polynomial is a polynomial and the domain will be all real numbers. But this is not a polynomial, so we may have to consider, and we do, have a number that is not in the domain. All right, so now let's see if we're increasing or decreasing. So pick a negative number, plug it into the derivative. So let's say f of -1, f prime of -1. 4 times -1 to the -1/3 minus 4, that's going to be less than 0. So we are negative, which means we're decreasing. Pick a number between 0 and 1, let's say a half. 4 times 1/2 to the -1/3 minus 4. And I believe that is also going to be negative. And then pick a number greater than 1. 4 times 2 to the -1/3 minus 4. I believe that will be positive. So here, neither, because we're decreasing, but here we have a minimum. Okay. So let's see. Now we just need to plug in f of 1. And we get f of 1 is 6 minus 4, which is 2. And so that will be our minimum. Don't need to worry about 0 because it's not a minimum or a maximum. All right. Let's see. Find the maximum weekly profit and the price that companies should charge to realize maximum profit. So we have a cost function and a demand function. Let's get our revenue function. So the revenue function is going to be this P function times Q. So that's 50 minus 2Q times Q. That would give us 50Q minus 2Q squared. So let's get our profit function. So profit will be revenue minus cost. So that is 50Q minus 2Q squared minus the cost, which is 100 plus 100, or 10Q. So combine our like terms, we did get 2Q squared plus 40Q minus 100. Now take the derivative. Scroll down a little bit. Take the derivative. P prime will be negative 4Q plus 40. Set that equal to 0. And we get Q equals 10. Now, this is a linear derivative. So if the derivative is linear, has a negative slope, so that tells us that it's going to look like that. So we know that it's going to cross the intercept at 10. So before 10, it's going to be positive. After 10, it's going to be negative. So we are increasing and then we are decreasing. So 10 is going to be a maximum. And then let's find P of 10. And P of 10, negative 2 times 10 squared plus 40 times 10 minus 100 is going to give us 100. Okay, so there's the idea. Follows the same steps every time. Derivatives, set it equal to 0, find the critical points. Are we increasing or decreasing? So you find your max and your min or neither, and then you plug it back into the original function.